All right, so we've talked quite a bit about making valid arguments and being able to justify assertions using logic. In this section, we're going to talk about logical fallacies first and then paradoxes. These are, in some sense, going to tell us about ways in which logic can be misused and abused to make incorrect arguments. And paradoxes are really more about the limitations of formal logic. So let's start by talking about logical fallacies. Now, we're familiar with logical fallacies because we hear them every day, right? You've heard somebody make a bad argument and think, that's not right. You know, something about that doesn't seem right. But we can really, we can break down the idea of a fallacy into two broad categories. The first being formal fallacies, which are just deductive arguments that are invalid. So we talked a lot about valid arguments. These are deductive arguments that are invalid, which means that the conclusion does not follow from the premises. So we'll see a bunch of examples of those momentarily. But we also are familiar with the idea of an informal fallacy. So these are just a result of error in reasoning in an argument that's used in natural language. So this is maybe the kind of thing that you might hear more often from your own students. And they're used in natural language, not using, symbolic logic, right? Not using P's and Q's and connectives, but actually using the meaning behind the statements. So keep in mind that we can have perfectly valid arguments which are not sound, right? In other words, that have false premises, and those are not really a formal fallacy, right? Because you could have a statement like, let's say something like, if Texas is in Canada and, if Texas is in Canada, then Texas is in Europe. Well, Texas is in Canada. Therefore, Texas is in Europe. Right? This reads like a whole bunch of nonsense because, right, the if-then statement, if Texas is in Canada, then Texas is in Europe, doesn't really feel like it means much of anything because Texas is not in Canada and Texas is not in Europe. However, this is an argument of the form if P then Q and P, Texas is in Canada, therefore we conclude Texas is in Europe, Q. This is really just an example of the modus ponens argument. This is a valid argument. It just doesn't really seem to make any sense. We can see how we could think about this as being an informal fallacy. We'll talk about this a little bit later. But keep in mind that modus ponens is a perfectly valid argument even though it's not sound, right? Even though in this case the hypothesis that Texas is in Canada is false, so it doesn't really feel like it should follow that Texas is in Europe. According to modus ponens, it does follow. All right, so a formal fallacy is one in which the conclusion does not actually follow for the premise. So let's give an example. If it is raining, I go to the movies. I go to the movies, therefore it is raining. This is a formal fallacy, and we can model it using, right, P implies Q. Right, we start with this conditional statement, if it is raining, then I go to the movies. I go to the movies is the conclusion of that statement, therefore it is raining, P, therefore P. Well, we know that this is not going to be correct, right? Because this is saying that if it is raining, then I'm going to go to the movies, but just because you go to the movies doesn't mean it's raining. You could very well go to the movies when it's sunny as well as when it's raining. But we can see in a truth table just exactly why this is an invalid argument. So remember, this is the invalid argument that they're making here. P implies Q, Q, therefore P is invalid. And in the truth table, we can see this because if we look at the premises, P implies Q and see where are they both true? They're true here and here, as well as here and here. In order for this to be a valid argument, the conclusion of P would have to be false. I'm sorry, the conclusion of P would have to be true in both of those cases, but it's not, right? It's actually false here. And this is a problem which tells us that the argument is invalid. This is an example of a formal fallacy. So this is really a violation of the logic of this argument. That last fallacy that we saw is sometimes called affirming the consequent. In other words, we affirmed that the conclusion of an if-then statement is true, and then concluded that the hypothesis was true as well. But again, that's not a valid argument. And it's related to another fallacy that we call the fallacy of undistributed middle. This can occur when you have an argument of the form, all x are y, z is an example of y, therefore z is x. Okay, so I'll give you an example of something like this. You might hear somebody say, let's see, all athletes are strong, and Ben is strong, therefore Ben is an athlete. Okay. In this argument, the common term in the premises, which is y, is the strong term, but it's not distributed to the conclusion, and it doesn't follow, right? Ben could be a non-athlete that's strong. Saying that all athletes are strong doesn't mean that the only strong people are athletes. It just means that every athlete is strong. But you can have strong people who are not athletes. So knowing that Ben is strong doesn't actually allow you to conclude that Ben is an athlete. This is an example of something we call the fallacy of undistributed middle. Let's look at another example of a formal fallacy. Remember, this is a valid argument here. This is what we had called the hypothetical syllogism. It says if you have two conditional statements, or P implies Q and Q implies R, that allows us to conclude that P implies R. The fallacy of four terms is an invalid argument. It's a formal fallacy that's related to a syllogism in which the fourth unrelated term is presented in the conclusion. So you might hear something like this. P implies Q and Q implies R, therefore S implies R, where S is some fourth unrelated statement, right? So you can't actually conclude S since it's not in the premises, so it really cannot be concluded in the conclusion. So this is an invalid argument and a formal fallacy. So formal fallacies are easy to spot using truth tables. All you have to do is build up that truth table, look to see where are all the premises true, and check whether the conclusion is also true in all of those cases. But informal fallacies are a little bit trickier to describe. I'll give some examples here. Hopefully I can actually fit them all. Okay. Some of them you might be familiar with, and I'll give you an example of each one of these. The first is the slippery slope fallacy. It asserts that taking a small step can start a chain of events that lead to much larger consequences. So I'll give you an example. You might hear a student say something like this, kind of catastrophizing. If I don't get an A in the class, how about this? If I don't get an A on this test, then I'll mess up my grade for the class, ruin my GPA, so I may as well just drop out. I think we've all had students that are as traumatic as this. Right, but while this might not be a formal fallacy, right, while this might not violate any sort of truth table logical laws, if we try to set this up as a logical argument, it's a fallacy in the sense that it's reaching conclusions that don't necessarily follow from the hypotheses. So this is an example of the slippery slope, right? So just this one small act of not getting an A on the test is going to lead to me dropping out of school. Slippery slope. All right, our next example is the equivocation fallacy. That occurs when you have a single term with two different meanings used in different ways but treated the same way in the logical structure. So an example of that might be hearing something like, beans are healthy and chocolate is made from beans, therefore chocolate is healthy. Well, I mean, I guess we're using beans in the same kind of sense here. Equivocation sometimes really uses words that are like homonyms or homophones that sound the same but really don't mean the same. When we say that beans are a healthy food, we're not really talking about cocoa beans. Those aren't things that we just eat on their own. We're talking about the kinds of beans that you might eat, right, in a salad or in whatever. And so saying that, well, because chocolate comes from beans, that means that they must be healthy, is really kind of using the term beans here in two different ways to reach a conclusion that really, right, doesn't make sense. Another example of an informal fallacy is the ad hominem fallacy. That involves attacking a person's character rather than attacking somebody's argument. You might hear, for example, somebody say that, let's say, we should not follow Alexander Hamilton's financial advice because he had an affair. I mean, it might be true that he had an affair. I think it's established. Because he had an affair. I think it's established that he did, but that actually doesn't really make the case that there's anything wrong with his financial advice. Those two things are not really related to each other. So you're attacking the character of a person rather than attacking their argument. If you wanted to make a case against his financial advice, you have to talk about his financial advice. Another example is called the post hoc fallacy. This happens when one event follows another and somebody incorrectly concludes that one event caused another. Sometimes you can see people kind of not knowing the difference between correlation and causation, and that can be an example of the post hoc fallacy. So you might hear someone say that every time I wore my Bruins jersey, they won. And reaching the conclusion that they need to wear their Bruins jersey in order for the Bruins to win. So if I don't wear my jersey, they will lose. I guess this is, in a way, you could sort of rephrase this particular example as a formal fallacy as well, where we assume that P implies Q and then conclude that Q implies P. But the idea here is that we think that this person thinks that they're causing the Bruins to win by wearing their jersey, and that as a result, if they need to wear their jersey in order for the Bruins to win. All right, couple more. The bandwagon fallacy suggests that something is right or correct just because a large mass of people are doing it or a large mass of people believe it. We certainly have heard this before. One example would be if you heard somebody tell you that Twilight by Stephanie Meyer is a masterpiece. And we know that it's a masterpiece because it has been purchased by over 100 million people. Right? So Twilight is a masterpiece because it sold 100 million copies. So yeah, just because something is popular does not necessarily make it a masterpiece, does not necessarily mean that it's good or that it's bad, right? But it's just because a large mass of people are doing something doesn't necessarily mean that it's correct or the right thing to do. The last example that we'll give here is the false premise fallacy, in which somebody reaches a conclusion by assuming a premise which is in fact false. Again, this is not a formal fallacy because arguments can be valid even when their premise is false. So as an example, you could hear something like the argument, all birds can fly, ostriches cannot fly, so ostriches are not birds. Right. The the formal argument here is technically correct, but the hypothesis that all birds can fly is false, which leads us to this conclusion, which is not actually true. Okay, so not a formal fallacy here, but this is more of a semantic fallacy where we're reaching a conclusion that doesn't really make sense based on a false hypothesis. All right, in the next video, we'll come back and talk about paradoxes.